This tape is on literal linear equations and substitution into equations. I will combine these two chapters into the one, since substitution into equations is a simple extension of literal linear equations. But I will begin with literal linear equations. And do chapter K next. In literal linear equations, the equations are essentially formulas which contain mostly letters. Literal linear equations is a chapter that's one of the more difficult ones on equations, but it is one that your science teacher wants you to learn especially well. Not much can be said about the material contained in this chapter that has not already been said in the first chapter on equations, chapter J. The difficulty here is that most of the time there will not be any numbers in the equation to reduce the problem to simpler form. The basic rules of equations, add, subtract, multiply, and divide, will have to be applied very carefully. If the equation contains brackets and fractions, these will have to be removed from the equation in order to deal with an ordinary equation. To do this, I suggest that you eliminate the denominators by applying the necessary rules for that, and then deal with the brackets next. Recall that in removing fractions from equations that you must find the lowest common denominator and use that expression to multiply it on both sides of the equal sign. It will take considerable time for you to complete the chapter because most of the time will be spent on solving a large variety of problems. In this example, if we have px equal to m, and I wish to solve for p, I'll put the letter that I want to solve for in square brackets beside the equation. We notice that in order to solve for p, we must get rid of the x. You look at the operation that connects the two letters for now, and notice that they are multiplied. So multiplication connects those two letters to form that expression. To eliminate the x so that p is alone, you have to disconnect that operation. And disconnecting an operation of multiplication is simply applying the opposite operation. The opposite to multiplication is division, so therefore we'll want to divide both sides by x. So px divided by x equals m divided by x. Notice that whatever you do to one side of the equal sign, you will have to do to the other. Now, you can either write it as a division problem like you see it, or this is exactly the same by x equals m divided by x, expression leaving p on the left and m over x on the right. The next example, t plus q equals y. T plus q equals y, and I want to solve for q. Plus t plus q equals y. To disconnect that operation, to remove the t, we would subtract t from both sides. Write in your solution and take some shortcuts. T plus q minus t equals y minus t. Since you're removing t, you know that the result will be 0 for no reason. So q then is equal to y minus t, and we have solved for the variable required. In another example, I have L minus R equal to M. And in this problem, I want to first solve for letter L, and then I will do the problem starting and solve for R. First, L. The operation which connects the letter that we want to solve for and the letter that we don't want connected with that letter is subtraction. L subtract R. The opposite to that operation is addition, and addition will disconnect the operation that now connects them. So adding R to both sides, we end up with L by itself equal to M plus R. To solve for R, I would essentially write, let's begin again, L minus R equals M, equal to R plus M. Now, R plus M is an addition between R and M, which we have to disconnect by subtracting M. And when you subtract M, you end up with L minus M equal to R. Now, I'll do this another way. If we write it this way, minus R plus L equals M, we can look at that as an addition problem when written in this fashion. The normal process then to get minus R by itself is to subtract L from both sides, and so R will equal to M minus L. But we don't want negative R, we want positive R, so we will either multiply by -1 both sides to get positive R, or divide by -1 on both sides to get positive R. And so when we do either one of those operations to this line, R becomes minus M plus L, or L minus M, which is what I have over here on the left. Continuing then with Chapter K, substitution into equations. Before doing the chapter on substitution into equations, you should have completed the chapter on literal linear equations, because as I have explained, the substitution into equations chapter is an extension of literal linear equations. In science and engineering, students are expected to manipulate formulas for a required variable and then substitute numerical values for the other given letters, which are the parameters of the problem, until a single number is obtained. This is essentially what you would be doing if, for example, you use the formula in a computer program and you wanted to solve for a particular letter. You must have that letter on the left-hand side of the equal sign and all the other letters on the right-hand side. Here is an example. A well-known formula dealing with volume is volume equals length times width times height. Let's suppose we want to determine the height given that W is 7, L is 3, and V is 56. As far as the units of measures are concerned, we won't bother with that. And we want to solve for H. The first step should be in solving for H so that it is expressed as a single variable on the left-hand side. If you divide by L times W, you will end up with H by itself. V divided by L times W is then the result that we are after. Of course, we can rewrite it and have H on the left-hand side. L times W, or simply LW. Now, by substitution, we can find that H is equal to 56 divided by 3 times 7, which is 56 over 21, which amounts to 2 and 14 over 21, which is equal to 2 and 2/3. Dividing 7 into 14 and 7 into 21.